Okay, we are rolling. All right, good morning, boys and girls.
Good morning, Miss Antonelli. Because we all have PE. Yeah.
You have PE today?
Yeah, that's why I'm happy.
All right. So one good thing is we have our hover cam or our technology up and running today. We've been outed. And we have Miss LaRue here, so it is a good Thursday.
Let's hope that this new hover cam isn't going to sleep. It doesn't want to do its job properly. Or out.
All right, ladies and gentlemen, if you can clear your desks of your independent reading books, make sure your science text and notebooks are out because we're jumping right into science today. Okay, you can open up your science notebook to 2 blank pages after the demonstration that I'm about to do. All right, after the demonstration I'm about to show you and explain what we're doing in science, we'll be writing down a new focus question. So what I want you to do is just be prepared, open up to 2 blank pages, write the date at the top right corner, number the pages, and then we'll begin. I don't want to give you the focus question until after I show you and demonstrate the topic. Okay, find a piece of paper if you don't have your notebook for some reason. And we'll tape it in later, but it should be in your desk. Thumbs are up when you have the date and your pages are numbered at the bottom. Zach's ready, Kaylee's ready, so while the side of the room is ready, they're out. Henry, can you open your book, please? Put the date so you're ready. Should be the last few pages unless you forgot. That's okay, Michael. Keep counting. All right.
I gave you my note. Wait.
Right. Did you finish our roll? Jason, I am so sorry. Okay, right here. All right, it looks like this side of the room is done. Does anyone need more time on this side of the room? No? We're going to begin, okay? So let me explain what we're doing in science. Okay? We've been learning about the sun, the moon, and what?
Planets.
Planets, okay? This investigation is going to piggyback off of the investigation we did when Miss LaRue was here last, which was learning about all the interacting parts in our solar system. Okay? Today we're going to be learning about gravity and the importance of gravity in our solar system. So the word gravity, we haven't discussed it technically really in science yet. It's come up a few times. You have some background knowledge about it. How many of you have heard of the word gravity before? How many of you think you could give me a definition of what gravity is? Oh, let's see. Let's see. What do we think we know about gravity? Emma, what does gravity mean to you? Can I show you something? If I let go of this ball and string, what do you think will happen?
It'll fall.
Let's test it. Did it work?
Yeah.
Why do you think it fell to the ground? What force do you think maybe? Gravity. Okay, so gravity is a force that on Earth makes everything go to the ground. Meadow.
Gravity is what keeps us from going into space and
what keeps us on Earth. We're grounded on Earth. We're planted on Earth. How many of you have heard of Sir Isaac Newton before? Some of us? Sir Isaac Newton, he was a scientist, right, Dimitri? Do you know what he said? His famous quote that he said? You might know it once I said. Do you know it, George? What do you think it is? That's okay. So let me tell you the quote, and then we're going to move on, okay, guys? I love how there's so much participation. Okay, so listen to this, and then tell me if you've heard this before. Whatever goes up must come down. Okay, so gravity is a force, okay? It's a force, and when we're on Earth, the force is it's pulling us back down. Okay? Forces are push and pull. How many of you did machines and civil machines in second grade a long time ago? Do you remember building and you learned about force, pulling, and pushing? Okay, so now it's time for our demonstration. Okay, before we get to the focus question, basically I want you to think about how gravity is important for our solar system and is important for us on Earth. You said something that was important. I do want to re-mention something how gravity keeps us on Earth. What about the solar system in general and all the planets? So we have our sun. So let me back that up for a second. Maybe I'll give you the focus question before I do my demonstration. So hold on. I don't have a question for you yet, but watch this. We have our sun, we have our Earth, and we have our 7 other planets and everything else interacting. Everything orbits around the sun. What do you think keeps the Earth from just spinning off into space? Everybody? Gravity. Gravity. Okay? Gravity. So today what we're going to do is we're going to investigate. I'm going to do a mini demonstration. Hands down for a second, okay? Mini demonstration with the ball and string, which a lot of you said, what is that for today? Okay, and then we're going to observe what happens during the demonstration. Okay, and we're going to try to answer the focus question, which is why do planets orbit the sun? Okay, so our focus question is why do the planets orbit the sun? Earth orbits the sun because of gravity. You've already predicted that our planets orbit the sun because of gravity. So now that we have that answer to our focus question, but we want to actually investigate it, watch what happens when I show you what gravity can do, okay, and what happens when we don't have gravity. So I'm going to demonstrate that. So let's write focus question down first before I do that demonstration. To investigate this, we'll watch a demonstration, we'll watch a quick video, and then we'll do some research. Since we already talked about that, I wanted to get that out there. Yes? Good. Well, we're going to let me demonstrate that. Exactly. We've talked about that, how we move so fast. We don't feel that we're on Earth and that Earth's rotating, you mean? All right, thumbs are up when you have that focus question written down so we can get right into the demonstration. Thumbs are up when you have your focus question written down. I know you have so much to say, but I want to make sure we stay on task. All right. Once you have your focus question written down, stand up, put your chairs in. Okay. Okay. So let's do a quick review. When Earth orbits the sun, what is the shape of the orbital path?
Oval.
Oval, circular? I would accept both, okay? A circular oval path, okay? So that means the planets are not traveling in a straight line, correct?
No.
Okay. So right now, what I'm going to do with the ball and string is I'm going to try to keep the ball in, which is going to represent, it could represent Earth, it could represent any object in space that actually orbits the sun. Okay? So let's say I'm the sun, and I'm going to make this orbit around me. How do you think this is going to orbit around me? Do you think it's possible?
No. We don't have enough gravity.
I have a so it's a demonstration. It's not the exact model of our solar system, but let's say this is Earth and I'm the sun. Dimitri?
It won't because the Earth has more gravity than you do, but every piece of mass has gravity but not as strong.
Okay, so you're saying this would gravity would win and it's not going to orbit. Okay, what if I put it into motion?
Then it would.
Then it will. Okay, so because this is a demonstration, I'm going to put it into motion. I'm going to make this Earth orbit the sun, which is me, in a circular path. But here's what I want you to notice. Are you ready? I want you to notice what happens when I let go of the string. What path does Earth travel in? So I'm going to be doing like a lasso here, right? We're going to make Earth orbit me, the sun, this is Nelly, and I'm going to let go. When I let go at that moment, that's going to represent no gravity. And what would happen to Earth and other objects if there was not gravity? I want you again to pay attention to the path it takes. What path does it take? Does it take a windy path? Will it travel straight? Okay, what do you think? A prediction?
It would or fall and continue falling because space is infinite, or it would go all zigzagging, or it will all go straight.
You have a lot of predictions. Well, let's see. Let's demonstrate. One last thing. Are you ready?
Yep.
One last thing. You want to be on your guard because we don't want this to hit you. Okay, so I'm going to say when I'm going to let go, so you don't have to duck. It's a styrofoam ball, so I practiced it with her.
You practice hitting yourself
Stand up.
in the head.
Don't touch my beautiful face.
But all you have to do is just cover your eyes a little bit like this, okay?
You practice hitting yourself in the head.
No, I practiced on my younger sister. I have to say. Ready? What do you notice? Is it orbiting?
Yeah.
What's the shape?
Oval. That is circular. No, it's oval.
Okay. Now ready? I'm going to let go at the count of 3. But you have to keep your eyes open to watch the path it travels. 1, 2, 3. I did good. I didn't hit anybody. Don't throw it. Don't throw it.
What's straight? It goes straight down.
Okay. Hold on.
Straight the went down.
Yeah. So I heard a lot of people say it went. So I would say the path went straight and then eventually it
Went
down. So my question to you is, what would happen to Earth and all the objects in the solar system if we didn't have gravity? What keeps us from spinning out into space and never coming back? You all say gravity, correct? So this is a demonstration. The string represented gravity. This ball represented Earth, and I was the sun. Okay, do you want to see it one more time before we go?
Yeah.
Okay, so some of you said it went diagonal. I'll do it one more time, and I'm going to explain what we're going to do next to investigate this focus question further. Got it? Okay. Actually, do I have a student volunteer that would like to do it? They're out? So just in case you missed it the first time, I think most of you caught it, but let's see. Let's come a little bit over here. Hold it right here. Don't do it too fast, but go ahead. Get it up into orbit. Okay.
Don't hit.
Ready? Try again. And when I count to 3, you're going to let it go. 1, 2, 3. All right. Thumbs are up if you know what path it went in. Thumbs are up. Thumbs are up if you know what path it went in. And you're ready to tell me. Whisper to your neighbor, what path did it go in?